To understand twisted questions on your industrial journeyman exam, first read each question multiple times to fully grasp its meaning. Highlight or underline important words that define the concept being tested. Next, break down the question into smaller parts to understand its logical flow. Examine the context of the question for hints or supplemental information. Try rewording the question in your own language to gain clarity. For study strategies, first familiarize yourself with the specific topics covered in the exam by reviewing the test blueprint. Secondly, solve as many sample questions as possible, focusing on understanding the concepts rather than memorizing answers. Thirdly, consider attending study sessions or workshops for guidance from experienced professionals who can provide additional insights. Fourthly, analyze your performance to identify areas where you consistently struggle and focus on improving those concepts. Fifthly, seek support by collaborating with peers or joining study groups to exchange knowledge. Other helpful tips include the following. Manage your time wisely by allocating specific time slots for studying and practice. Stay positive and don't let setbacks discourage you. View them as opportunities for learning and improvement. Take regular breaks to help refresh your mind and improve focus. If self-study isn't effective, consider hiring a tutor who can provide personalized guidance. If you encounter a question that you don't understand, don't hesitate to ask the testing center staff for assistance. Review the fundamental concepts of electricity. This includes Ohm's law, which states that voltage equals current times resistance or voltage equals amps times ohms. Understanding this relationship is crucial. Practice applying Ohm's law in different scenarios to calculate voltage, current, or resistance when given the other two values. Review series and parallel circuits. In a series circuit, the current is the same throughout, and the total resistance is the sum of individual resistances. In a parallel circuit, the voltage is the same across all branches, and the reciprocal of the total resistance is the sum of the reciprocals of individual resistances. Understand how to calculate total resistance, current, and voltage in both types of circuits. Learn about alternating current, referred to as AC, and direct current, referred to as DC. Direct current flows in one direction only, while alternating current periodically reverses direction. Understand the characteristics of AC waveforms, including frequency, period, amplitude, and root mean square, which is referred to as RMS value. Know how to convert between peak, average, and RMS values for sinusoidal waveforms. Study transformers and their operation. A transformer changes voltage levels while maintaining power. The turns ratio determines the voltage transformation ratio. Understand the relationship between voltage, current, and turns ratio in a transformer. Be familiar with transformer types such as step-up, step-down, and isolation transformers. Learn about different types of electrical components, including resistors, capacitors, inductors, diodes, and transistors. Understand their functions, characteristics, and applications in electrical circuits. Know how to identify component values and tolerances based on color codes or markings. Familiarize yourself with common electrical measuring instruments such as multimeters, ammeters, voltmeters, and oscilloscopes. Understand how to use these instruments to measure voltage, current, resistance, frequency, and other electrical parameters. Learn about the proper safety precautions when using electrical measuring instruments. Study the National Electrical Code, referred to as NEC. The NEC provides guidelines for safe electrical installations. Familiarize yourself with the key articles and sections of the NEC that are relevant to your work as an electrician. Understand the requirements for wiring methods, overcurrent protection, grounding, bonding, and equipment installation. Learn about wiring methods, including conduit, cable, and raceway systems. Understand the different types of conduits, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Know how to properly install and support conduit systems. Learn about cable types, such as non-metallic sheathed cable, armored cable, and underground feeder cable. Understand the applications and limitations of each cable type. Study overcurrent protection devices, such as fuses and circuit breakers. Understand the purpose of overcurrent protection, which is to protect conductors and equipment from overloads and short circuits. Learn how to select the appropriate size and type of overcurrent protection device for different applications. Know the difference between time delay and instantaneous trip circuit breakers. Learn about grounding and bonding. Grounding provides a low impedance path for fault current to return to the source, while bonding ensures that all metallic parts of an electrical system are at the same potential. Understand the importance of grounding and bonding for electrical safety. Know the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Study motor control circuits. Understand the principles of motor control, including starting, stopping, reversing, and speed control. Learn about different types of motor starters, such as magnetic starters, reduced voltage starters, and solid-state starters. Know how to troubleshoot motor control circuits. Familiarize yourself with programmable logic controllers, referred to as PLC. PLC are used to automate industrial processes. Understand the basic components of a PLC, including the central processing unit, input modules, output modules, and power supply. Learn how to program a PLC using ladder logic or other programming languages. Practice reading and interpreting electrical drawings and schematics. Electrical drawings provide a graphical representation of electrical systems. Understand the symbols and conventions used in electrical drawings. Be able to trace circuits and identify components based on electrical drawings. Develop your troubleshooting skills. Troubleshooting involves identifying and resolving problems in electrical systems. Use a systematic approach to troubleshooting, starting with the most likely causes. Use electrical measuring instruments to diagnose faults. Be able to interpret the results of your measurements and make informed decisions. Practice your problem-solving skills. The Journeyman exam often includes problem-solving questions that require you to apply your knowledge and skills to real-world scenarios. Practice solving these types of questions to improve your ability to think critically and solve problems effectively. Consider the following strategies when answering questions. Read the question carefully and make sure you understand what is being asked. Identify the key concepts and principles that are relevant to the question. Eliminate any answer choices that are obviously incorrect. If you are unsure of the answer, make an educated guess based on your knowledge and experience. Review your answers before submitting the exam. Managing your time effectively is crucial for success in the Journeyman exam. Before the exam, estimate how much time you should spend on each section or question. During the exam, keep track of the time and pace yourself accordingly. If you are spending too much time on a particular question, move on and come back to it later if you have time. Stay calm and focused during the exam. Test anxiety can negatively impact your performance. Practice relaxation techniques to reduce anxiety and improve focus. Get enough sleep the night before the exam. Eat a healthy meal before the exam. Arrive at the testing center early so you have plenty of time to get settled. Read carefully. Understanding the question is the first step. Identify key terms by underlining important words. Analyze the structure. Breaking down the question helps. Look for clues in the question's context. Rephrase the question to better understand it. Consider attending study sessions or workshops. Also analyze your performance. Consider collaborating with peers. Manage your time effectively. Stay positive throughout the exam. Take regular breaks. Consider hiring a tutor for personalized guidance. Don't hesitate to ask for clarification during the exam. Remember the following electrical formulas. For direct current circuits, power, measured in watts, equals voltage, measured in volts, times current, measured in amps. Power equals I squared times R, where I is the current measured in amps and R is the resistance measured in ohms. Also voltage equals current times resistance, or voltage equals amps times ohms. For alternating current circuits, power equals voltage times current times the power factor. The power factor is the cosine of the angle between the voltage and current waveforms. Apparent power, measured in volt-amps, equals voltage times current. Reactive power, measured in volt amps reactive, equals voltage times current times the sine of the angle between the voltage and current waveforms. Electrical safety is paramount. Always de-energize circuits before working on them. Use appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Follow lockout-tagout procedures to prevent accidental energization of circuits. Be aware of potential hazards, such as arc flash and electrocution. Remember to always verify that a circuit is de-energized before working on it using a voltage tester. Never assume that a circuit is de-energized just because the switch is off. Inspect your tools regularly to ensure that they are in good working condition. Replace any tools that are damaged or defective. Be aware of the presence of overhead power lines and maintain a safe distance from them. Never work in wet conditions. Use ground fault circuit interrupters, referred to as GFCIs, in wet locations. Follow all applicable safety regulations and codes. If you are unsure about something, ask for help from a qualified electrician. Remember the requirements for conductor sizing. The ampacity of a conductor must be sufficient to carry the load current. The overcurrent protection device must be sized to protect the conductor. Use the appropriate tables in the National Electrical Code to determine the ampacity of conductors and the size of overcurrent protection devices. Consider the directing factors for ambient temperature and the number of conductors in a raceway. The NEC Table 310.15 provides ampacity correction factors for ambient temperatures other than 30 degrees Celsius, which is 86 degrees Fahrenheit. The NEC Table 310.15 also provides adjustment factors for the number of current-carrying conductors in a raceway or a cable. Understand the requirements for equipment grounding. All non-current carrying metal parts of electrical equipment must be grounded. Grounding provides a low impedance path for fault current to return to the source. Use the appropriate grounding electrode system for the type of service. The NEC Section 250.50 covers grounding electrode systems. Understand the requirements for equipment bonding. All metal parts of an electrical system must be bonded together to create a low impedance path for fault current. Bonding ensures that all metal parts are at the same potential. Use the appropriate bonding methods and materials. The NEC Section 250.92 covers bonding requirements. Remember the requirements for wiring methods. Use the appropriate wiring method for the type of installation. Consider the environmental conditions and the type of occupancy. The NEC Chapter 3 covers wiring methods and materials. Understand the requirements for overcurrent protection. Overcurrent protection devices must be sized to protect conductors and equipment. Use the appropriate type of overcurrent protection device for the application. The NEC Article 240 covers overcurrent protection. Learn about the different types of electrical equipment, such as transformers, motors, and generators. Understand the principles of operation of each type of equipment. Know how to install, maintain, and troubleshoot electrical equipment. Study the requirements for special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. Understand the unique electrical requirements for each type of occupancy. The NEC Articles 500 through 590 cover special occupancies. Familiarize yourself with the latest edition of the National Electrical Code, referred to as the NEC. The NEC is updated every 3 years. Make sure you are using the most current edition of the NEC when designing and installing electrical systems. Obtain a copy of the NEC from a reputable source. Study the NEC regularly to stay up to date on the latest requirements. Consider attending NEC training courses to enhance your understanding of the code. By following these tips and strategies, you can improve your chances of passing the Industrial Journeyman exam and obtaining your electrical license.